Hi, welcome back to hostboxcse channel and back to the exclusive tutorial for computer architecture and organization. This is a tutorial helpful for GATE UGC NET, some of the college level competitive as well as the university exams also. Today we are going to see the topic called catch replacement. So in the previous session I explained about the locality of reference, where is a principle of catch operation, and we have two types. What is it? Temporal as well as a spatial locality with the examples. Locality of reference with the spatial type, and also temporary with some examples, real time examples. Today's session we are going to see the catch replacement algorithm. Why we need catch replacement algorithm? What are the types of catch replacement, and just introduction of the types. Now go for catch replacement. If you want to understand this catch replacement, just assume that you have a cache memory and main memory. You have blocks of 0 to 16 like that. That means total 16 blocks, and here cache we have only cache 0, block 1, 2, 3 and so on. For better clarity we go for another option, another mode. So here why we need replacement, because just let's assume that CPU want to access the block data from the block 5. Let's assume that the CPU want to, the block 5 is here, in the main memory the block 5 is there. So in your cache you have a place for only B0, B1, B2, B3. So what happen if your cache is filled? Now assume that your cache is filled. So the CPU want to access data from B5, block 5. So what will happen here? There is no place in the cache. So what we can do means, now let's go for the replacement procedure. So in the main memory the data will be in the form of frames or pages. That's not a matter. Based on your replacement we can do interchange the data. So here what will happen means, now there is no place. Now let's assume that what will happen when you want to request B5, we can go for replace now. So in the now what we can do means, we can interchange data. That means we can send the B0 to the main memory, and we will get the empty place. In the empty place we can replace this B5. So B5 will come to this cache memory area, and we can access. Now the CPU can access data very fast. So very simple cache replacement. So whenever cache is full, it will send some block to the main memory, and from the main memory it will fetch the required block with data. That the copy of the data will move to this cache, and we can access very fast. The data we can access very fast. This is the way of using the replacement algorithm. Let's back to P. Now the question is, why we need? Because there are some reasons why we need a catch algorithm. Replacement algorithm means, first one, it is always needed for set associative and associative mapping, as you know, and also used to minimize misspelling penalties for future reference, and also hit increase. That means what? Hit rate will be increased here. So used to minimize mispenalties. What we already told you many points about this cache memory, individual as well as DAD mapping and all the concept. So whenever the data is not on the cache, what happens? The CPU, main memory is there. CPU is very fast. So whenever the CPU or processor requests data from cache, it will get it very fast. If the data available data is not on the cache, what happens? It moves the main memory and fetches data. So it takes some time. That's called miss penalty. So if you want to minimize this miss penalty, we need help of catch replacement, and also hit increase. So hit rate increase means what? This average access time. So when you use this catch replacement algorithm, you can definitely go for the increase the average access time. For example, if you take 40 seconds to fetch the data from the main memory or bottom there, if you use this hit ratio concept, what happens? It reduces 20 seconds like that. So drastically it reduces the access time also, speed access. It permit the speed access when you go for the catch replacement algorithm. Now what are the types of replacement algorithms? There are 4 types there. One is called random, another FIFO, that is first in first out, another is the LRU, least recently used, and another is the MRU, most recently used. Out of this, FIFO and LRU is the main, very important. First one, random. Here random means what? Here the block can be replaced randomly. With just is in the diagram. Then FIFO, in FIFO what happens? A block which entered the first will be replaced first. And LRU list, this is the one where associated with the temporal locality, where we discussed in the previous session of locality of reference. In LRU what happens? The block which is not referred for longest time will be replaced. And MRU, the block with less reference will be replaced. So these are the just introduction of these points. The upcoming sessions I will explain one by one what is PIPO and LRU and MRU, how it will helpful to increase the hit rate as well as the minimize the miss penalties and so on. If you have any queries or comments, please communicate with us in the social media. And thanks for watching. Please like, share, comment and subscribe. Press bell icon for more updates. Thank you.